Welcome back to the Math Professors. I'm Professor Van Hamlin, and we're going to do Laplace transforms today. If you like our content and want to help us grow our channel, please consider liking, subscribing, and sharing. So let's get into it. So for Laplace transform, let f be a function defined for all t greater than or equal to 0. Then the integral, the Laplace of f of t, defined by this integral, is going to be the integral from 0 to infinity of e to the minus st times f of t dt. So if you're trying to find the Laplace of the function f of t, you pop it into here, and then you have to find that improper integral. So let's determine the Laplace transforms of these two functions. So first I want the Laplace transform of 1, and then we'll do the Laplace transform of t squared. We'll do a couple more after this as well. So first, if I want to find the Laplace transform of 1, we know that the Laplace of this function 1 is going to be equal to the integral from 0 to infinity of e to the minus st times f of t, in this case is going to be 1, dt. So we have to integrate this with respect to t, which really says that s is a constant in this format. So when I take the integral of this thing, the integral of 1 is just going to be 1, so I only have to take the integral of e to the negative t with respect to t. So the integral of e to the negative st with respect to t is going to be equal to e to the minus st divided by, that constant, negative s, and we're going to evaluate this from 0 to infinity. Now I'm not going to do the limits of these things. We're just going to make this quick, so I'm going to mess up the notation a little bit. So I'm just going to write the infinity in these spots, knowing that I'm actually talking about a limit here. So this is going to be equal to e to the minus s times infinity all over negative s, minus, this negative, we'll write it still down here, e to the minus s times 0 all over negative s. Now, what we know is that this is going to go to negative infinity, assuming s is greater than or equal to 0. So this term right here is going to go to 0. And e to the, this positive s, so this negative times 0 is still going to be e to the 0 all over negative s, which is going to be minus this minus s, which is going to be plus 1 over s. So this is equal to 1 over s. Now let's do the exact same thing for this one. So if I want to find Laplace of this new function, t squared, this is going to be equal to the integral from 0 to infinity of, e to the minus st times my function, which is t squared, dt. Now again, s is going to be a constant. We're going to integrate with respect to t, assuming this thing is positive. And the way to do this is it's going to have to be done by parts. And I'm going to, we'll do it one by one instead of doing tabular, though tabular would be quite a bit easier. But we'll do it one at a time. So in order to do this, we know that u is going to be equal to t squared. dv is going to be equal to e to the minus st. So du is going to be equal to 2t dt, and v is going to be equal to e to the minus st all over negative s. So this is now going to be equal to, uv minus the integral of v du. So there's your biporous formula. So uv is going to be equal to minus t squared e to the minus st all over negative s, evaluated from 0 to infinity, minus the integral of v du, which is going to be equal to, this minus and minus is going to be a plus, so I can pull out that minus and say plus. This is going to be 2t e to the minus st all over s dt. And this is going to be from 0 to infinity. So what we're going to have to do is we're going to have to, do this thing by parts again. I'm going to say that the 2t is going to be equal to the u, and then the e function with this constant is going to be equal to the dv. So u is going to be equal to 2t, du is going to be equal to 2 dt, and then dv is going to be equal to e to the minus st all over s. I know I can pull out the s, but it's too late for me now. So v is now going to be equal to the antiderivative of this is going to be minus st divided by that negative s, so this is going to be minus s squared. So again, setting this up, this is going to be equal to minus t squared e to the minus st all over negative s plus, well, we're going to evaluate this entire thing from 0 to infinity. So this one is going to be uv minus the integral of v du. So this is going to be 2t e to the minus st all over negative s squared minus, the integral from 0 to infinity of v du. So this is going to be 2e to the minus st all over negative s squared dt. Now, again, this is evaluated from 0 to infinity, so is this. So when we're done, I'm just going to evaluate the entire thing from 0 to infinity. So this is now integrable. So this is going to be equal to minus t squared e to the minus st all over negative s plus this, well, this negative. This is going to be 2t e to the minus st all over s squared. And then this minus and minus is going to become plus. S squared is going to be on the bottom. The integral of this thing is going to be 2e to the minus st, again, divided by another negative s. So this was positive, so now this is finally going to be, minus s cubed. And we're evaluating the entire thing from 0 to infinity. So let's kind of talk about what happens when we plug in infinity. So evaluating this function at infinity, well, we can do L'Hopital's rule for each one of these pieces. But if I was going to ask, what is the limit as t goes to infinity of, say, this piece right here, this is going to be the minus, I'll just cancel those out. I'm going to have a t squared, and 1 over s because it's a constant, and this is going to be all over e to the st. So doing L'Hopital's rule, this is going to be 1 over s, the derivative of the top is going to be 2t, the derivative of the bottom is going to be se to the st. And then we're going to have to take the limit of that as well. So the limit as t goes to infinity of 2t all over e to the st times s again. So pulling that out, I have 1 over s squared, and times the limit as t goes to infinity. Well, let's take the 2 out as well. 2. So the derivative of t is going to be equal to 1. The derivative of this is going to be equal to se to the st. And we can see that as t goes to infinity, this thing is going to go to infinity, so this is going to spit out 0. So we can see that I can do this for this, I can do this for this, and also do this for this piece here. So each one of these, when you plug in infinity, is going to be equal to 0. So then we're just going to plug in t is equal to 0. Subtracting that, so minus when t is equal to 0, this is going to be 0 squared times e to the 0, which is going to be 0. This is going to be minus 2 times 0, e to the 0, which is 1, so this is also going to be equal to 0. And then minus when t is equal to 0, this is going to be equal to 1, so this is going to be, this is going to be equal to 1, so this is going to be 2 over s cubed. Finally spitting out, a negative is going to be 2 over s cubed. All right, so let's do a couple more, just like the common ones you guys are going to see. Let's do an exponential, and then let's do a trig function, and then we'll start with the piecewise. So let me pause this and set them up. All right, so let's find the Laplace of e to the 4t. So we know that this is going to be equal to the integral from 0 to infinity of e to the minus st times, the function I'm doing the Laplace of, so e to the 4t, and this is going to be dt. So what we can do is we can simplify this exponential. This is the integral from 0 to infinity of, e to the 4t divided by e to the minus st. So what I know I'm going to do is I'm just going to subtract these exponents and combine that base. So this is e to the 4t minus st dt. And pulling out that t, because I really want this to be e to a constant times t. So this is going to be 4 minus st dt. So now when I integrate this exponential function, you know that it's going to be equal to itself divided by that constant. Now we're going to evaluate this from 0 to infinity. So when I plug in infinity, it might be easier if I show this as a positive constant. So what I'm going to do is I'm going to factor out that negative. So this is e to the minus. We have s minus 4t all over, I guess I could still say this minus s minus 4 evaluated from 0 to infinity. And remember that we have to now evaluate these things at infinity. Excuse my notation, but sometimes it's easier just to look at it this way as opposed to writing these limits all the time. Minus a, well, this is going to be negative, so this is going to be plus. We're going to plug in 0 e to the minus s minus 4 times t, oops, not times t, but times 0, all over negative s minus 4. Oh, not negative, I combine those. Okay, so my goal really is to show that, this piece right here is going to go to 0 because, s being positive, that means that this is going to go to, well, this really is only going to go to 0 assuming that, s is bigger than 4. We have to verify that this is positive. So, this is true if s is greater than 4, as opposed to the other one when s was greater than 0. So when that thing is greater than 4, this thing will be equal to 0. So what we're going to get is that will disappear. This will be e to the 0, which is going to be 1. So this is going to be 1 all over s minus 4. All right, let's do the trig function next. All right, so here's the setup for the exercise. I want to determine the Laplace transform with the cosine of t. So we know by definitions it's the integral from 0 to infinity of e to the minus st. Cosine of t, dt, whatever is here, goes here. So now we're going to have to evaluate this integral. So in order to do this, we can tell that, again, this is a by parts, but this is one of those by parts to where you have an exponential and you have a trig function. So this is going to be one of those repeated ones. And you'll see what I'm talking about in just a second here. So let's set up our substitution. So u is going to be equal to, let's say, e to the minus st, and let's say dv is going to be equal to the cosine of t. It won't really matter when you're doing this by parts what you pick for your u and v. It's gonna recycle anyway. So then du is going to be equal to the derivative of this, which is going to be minus se to the minus st. And then the antiderivative of this is going to be equal to the sine of t. Oh, I should say dt. So this now is going to be equal to uv, so e to the minus st sine of t, minus, well, evaluated from 0 to infinity, minus the integral from 0 to infinity of v du. So this minus sign is going to make that plus. And now I have s e to the minus st sine of t dt. And what we can see is, dang it, we got to do it again, right? I still have an e to the st. You can pull out that in this piece here. So we're going to do u is going to be equal to e to the minus st. du is going to be equal to minus se to the minus st. dv is going to be equal to the sine of t dt. And then v is going to be equal to minus the cosine of t. So evaluating this is going to be e to the minus st sine of t, evaluated from 0 to infinity, plus s times whatever we get here. Well, it's going to be uv, so this is going to be minus e to the minus st cosine of t, minus the integral of v du. So multiplying those is going to become positive. So this is going to be se to the minus st cosine of t dt. Now this is where that repeat comes from, is what I can see is if I pull out this s, I can put it here. And I see that I have that particular integral there, so what are we going to do with that? So let's spit this out, and I need to make sure that I evaluate that from 0 to infinity as well. And let's simplify this. So this is going to be equal to e to the minus st sine t minus, this is going to be se to the minus st cosine t, and both of those are being evaluated from 0 to infinity. And then s times negative s is going to be minus s squared times the integral from 0 to infinity of e to the minus st cosine t dt. Now remember, the original thing was equal to this. This was equal to the integral from 0 to infinity of e to the minus st cosine t dt. So that's what I have over here, that I have this is the same as what the original came out to be. And more importantly, it's minus that. So what I'm going to do algebraically is I'm going to add an s squared integral from 0 to infinity of e to the minus st cosine of t dt to both sides. So doing that over here, what I know is I can factor out this integral from 0 to infinity of e to the minus st cosine of t, and what I'm going to get is the coefficient of 1 here plus this s squared. And over here I'm going to have what's left over is this e to the minus st sine t minus s e to the minus st cosine t, and we're going to have to evaluate that from 0 to infinity. So what I know is in order to solve for, this piece right here is the Laplace transform. That's the original piece. So I'm going to have to divide this by 1 over x squared, but let's go ahead and evaluate this piece first. So let's kind of talk about what happens when you plug in an infinity. So for this term, when you plug in an infinity, we'll know that the sine function is a bounded function. So it's always going between -1 and +1. So, and what about this e to the minus st? Well, if I can guarantee that s is greater than 0, then when you pop an infinity, this is going to be e to the negative infinity, which will be 0. So this thing will be equal to 0 when I evaluate it at infinity, and this is bounded. So 0 times anything between -1 and 1, inclusive, is going to still be equal to 0. So this will be equal to 0 minus, this is going to be s, again this is going to be 0 times a similarly bounded function, so this will also be times 0 minus, now when I evaluate this at 0, e to the 0 is going to be 1 sine of 0 minus s, this is going to be times the, this will be 1 cosine of 0. Now we know that the sine of 0 is equal to 0, so that's gone. And actually I should have said, let's make sure. When you plug in 0, yep, this is going to be 1, this is going to be perfect. This is going to be 0, and then when you plug in 0, this is going to be equal to 1. So what we're going to get here on that right-hand side is this is going to be, well, all that's gone. So this is going to be minus this minus s, which is going to be positive s, is going to be equal to what's left over here. So finally, when I just evaluate this from 0 to infinity of e to the minus st cosine of t, in order to isolate this, I'm going to have to divide that by 1 plus s squared, so it's going to be equal to that original s that I got, all over 1 plus s squared. Now the last thing I want to do is a piecewise function, and that really should be the gambit of most of what you're going to kind of see in, as far as Laplace transforms, or at least doing them by hand. Alright, so let's look at a piecewise function. I want to do the Laplace transform of f of t, where f of t is defined by this piecewise function. And what we know is that the Laplace transform is the integral from 0 to infinity. So this is equal to the integral from 0 to infinity of, s of minus e of minus st times f of t dt. Now f of t is a piecewise function, so I'm going to have to split this from 0 to 1 of e to the minus st times my f of t from 0 to 1 is going to be 2t plus 1 plus the integral from 1 to infinity of e to the minus st times 0 dt. So when we set this thing up, we know that in order to do this, this is going to be equal to a by parts function. So when I'm done with this, I'm just going to do the work since we already done by parts, and to speed up this video, we're going to have minus 2t plus 1 all over s minus 2e to the minus st all over s squared evaluated from 0 to 1. And then when I do this part, well, the integral of 0 is going to be just, this is just going to be the integral of 0. So this is just going to be, 0. So when we're done with this, if I plug in 1 here, this is going to be minus 2 times 1 plus 1 all over s minus 2e to the minus s times 1 all over s squared. And then minus, when I plug in 0, this is going to be minus 2 times 0 plus 1 all over s minus 2e to the minus s times 0 all over s squared. And clearly, you know, that integral is 0, so it's going to disappear. So when we're done with this, simplifying, minus s, minus. So this is going to be equal to, when we're done, this is going to be minus 3 over s minus 2e to the minus s over s squared. Minus and minus is going to be plus 1 over s, and then minus this is going to be plus 2 over s squared. So again, if you like the videos and you want to help us grow our channel, please consider liking, subscribing, and sharing.